So yeah, today I'm going to be talking about the 21st century minerals industry, energy transition challenges, if there is such a thing as the energy transition, and we'll talk about that shortly. Opportunity, policies, influences on metal supply and demand. And like most mining related talks, I'm going to start off with a disclaimer, which is also an advert for the Silver State, Nevada. These are my views, not the views of the state of Nevada, but I would like to note that we consistently rank among the best jurisdictions for mining-related investment and policy. This is the Fraser Institute's report that came out a couple of weeks ago. We have more than 200,000 former mine sites with waste potentially prospective for metal extraction. There's been a lot of talk of mine waste, and we already dealt with mine waste in the Nevada revised statutes. Basically, if mine waste is abandoned for more than 10 years in the state, you can go and claim it as a placer. So, in other words, if you're interested in mining critical metals, mine waste, then Nevada is the place to be, but that also indicates the bias that I'm going to have in this talk. I am the state geologist though, so I get to be biased. What I'm going to start out with is, we've heard a lot about supply and demand. This is a kind of historical look at what we're mining right now and what we've mined since the 1950s. There's a huge range of commodities here, all normalized to production in 1956, or in some cases to the first year that data were available. It's a logarithmic chart. Basically, this is mine production showing everything going up to the left, up to the right, sorry, with the exception of arsenic. So arsenic is the only one of these wide variety of metals and commodities that we mine less of than we did in the 1950s. If you look up here on the right, basically this means that if you compare modern day copper mining, we mine 7.2 times more copper than we did in the 50s, nearly 50 times more gallium, nearly 40 times more lithium, 14 times more nickel, nearly 75 times more rare earths, and 3.85 times more zinc. Basically, this is kind of outlining some of the messaging you've heard already, that essentially minerals and metals are the things that underpin modern standards of living, and we're likely to see an acceleration in demand as a result of changes in society, move towards electrification, renewable energy, and so on. You can also say, well, okay, this is also influenced by population, so we'll have a look at this on a per capita basis. Basically, you can see everything's still going up to the right, with the exception of, in this case, arsenic, tungsten, and tin, and lead. But the fact is, every human on this planet uses 2.5 times more mined copper than they did in the 50s, 22.9 times more mined gallium, 27.4 times more mined lithium, 4.9 times more nickel, and so on. In other words, this just shows how mineral and metal intensive life is nowadays, and the fact that, you know, some of these things are accelerating up to the right up here indicates the impact of that energy transition. This is also just primary mining production. It doesn't incorporate any demand met by recycling, and recycling rates for a lot of commodities, not all, but for a lot of commodities are also increasing. So that's the kind of baseline we're dealing with. We are doing pretty well in terms of increasing the amounts of mined metal and mineral production over time. But the fact is, we know that the mining and metal demand is going to increase as a result of the energy transition. And this comes on top of essentially us as humanity mining more now than at any other time in our history. It's great news for the minerals industry, but some of the questions I'm going to talk about here are actually uncertainties. What metals are we going to need, and when? It's also more than just mining, but entire supply chains need thinking through. What are we already using? How and is policy affecting all of this? How will policy changes affect all of this? What about uncertainties? And uncertainties is a key thing I'm going to talk about today. The uncertainties we face in the energy transition are huge. All we need to do is, and I'll talk about this shortly, compare predictions of demand for any metal you want for the next few decades and see how they vary. All of this, as we've heard already, is and will continue to be affected by policy, and predictions in terms of demand vary from significant deficit to possible surplus, depending on commodity, depending on time scale as well. I mean, what we're seeing right now, and I'll talk about metal prices briefly, is essentially a surplus in commodities like lithium and nickel. That will only be a short-term surplus, but it is depressing prices. It is causing issues with essentially project development and so on. And this is for Doug. I don't know if he's still in the audience. There he is. He said that the energy transition isn't happening. This is the kind of Chinese example of the fact that the energy transition is sort of happening. 30% of Chinese electricity is now supplied by renewables, 10% higher than here in the US. They're also exporting technologies outside of China. China's emissions are showing signs of peaking, and this is the clean energy capacity they're providing each year. So we've been talking a lot about US and domestic demand, but we do still live in a globalized society. We do need to develop domestic resources, but this also indicates that the competition for metals globally is not going to go away at any time soon, especially if this trend keeps on going up here. And this trend, in terms of their exporting of clean energy technologies, also increases. I'd just like to note as well, basically 10% of Chinese GDP is now related to clean energy technologies. It's overtaken real estate as one of their major players in terms of their enterprises and industry. So this is the kind of baseline we're facing right now. This is what a couple of speakers have already mentioned, some of the indicators of mineral demands that we may expect in the near future, driven by electricity, EVs and battery storage, wind, solar photovoltaics. And one of the questions is, can we get all of this? But the other question is, how reliable are some of these estimates? What are the uncertainties on some of these estimates in terms of how much of these metals we're actually going to need? How reliable is this modeling, and how does this compare to other modeling? We've heard that we're going to need a lot of copper. We know that copper is undoubtedly going to increase in demand. It's one of the kind of industrial metals. We use a lot of it for all sorts of reasons, never mind the impact of the energy transition. Demand increases are likely to go ahead. That's going to be somewhat independent of the mix of technologies used, and I'll talk about that shortly for the energy transition. But this graph here just shows an outline of the estimates or range of estimates we have of copper demand by 2030 and 2050. So these are the median. This is from a 2022 paper. These are the median values, but you can see there's some extreme values up here. There's also some extreme values down here. So the question is, which one of these is right? And this is just one commodity. And what I would say is that anyone who says they have the right answer is actually going to be likely wrong. We don't know how much metal we're going to need for the energy transition. We don't know which commodities are going to increase in demand significantly. Uncertainties, the copper is something that we know is going to increase in demand, but if this is the range of estimates for copper, then what is it going to be like for other metals that are even more reliant on the uptake of technologies that we have for the energy transition and so on. So I just wanted to highlight, and I'll talk about what these uncertainties indicate and what they're being driven by and why we need to consider them as we go through this talk. The other thing is that there's been a lot of talk about increasing demand, but if we actually look at more near-term modeling, these are estimates by IRENA, the International Renewable Energy Agency. This is published last year. What they're talking about is various key commodities here, some of which we talked about today. Their estimates are 2030, and they've got a range here. Supply estimates are 2030, and then the estimated balance. And the thing to note that some of these ranges are huge. For cobalt, we're talking 94% surplus to 35% deficit, and this is only 5 years away. If we can't predict what's going to happen in 5 years, how are we going to be able to predict exactly what's going to happen in 25 years and so on? We know that metal demand is going to increase, but the overall questions are which metals do you want to bet on? I'm not in the minerals industry, but if I'm an explorer, you're starting to think, well, what are these scenarios looking like? Do I want to look for nickel? Do I want to look for lithium? And the other thing is these are estimates of 2030, and how long does it take to get a mine up and running once you've made a discovery? About 10 years. So all of this kind of feeds in to some of the uncertainties we're facing about the energy transition and some of the uncertainties we need to deal with and actually start to model out and think about before we actually start to get into some of these major changes in metals. So in terms of the uncertainties we need to think about when we're talking about metal supply and demand, we certainly need to think about demand uncertainty, uncertainties over the metal and mineral demand for the energy transition, the timing of this demand, supply uncertainty, in other words, how much can we get out of the ground in terms of discovery, the time taken from a discovery to go into production, technology uncertainty. 20 years ago, did we think that lithium batteries were going to be really crucial? Has anybody heard of Greenbushes? Pegmatite mine, yep, exactly. I visited Greenbushes in 2003, so 22 years ago. The month after I visited in Western Australia, the mine shut down because there was no demand for the commodities they were producing. Now it's the world's major source of lithium, or one of the world's major sources of lithium. We're starting to think about things that are 20 or 30 years out. So how do we know exactly what to bet on? Certainly the technology uncertainty Even if we're going down the lithium-ion battery route, as I'll talk about shortly, the uncertainties are pretty huge here. And then the last thing I'll talk about here is policy uncertainty. I'm going to spend quite a lot of time on policy today, the negative and positive impact of policy related to mining, critical metal and mineral supply, and that's especially crucial right now after the last 6 months of various policies coming out here in the US. These uncertainties are interlinked. Demand and supply often operate at different timescales. That's why we get price volatility. That's why we can get short-term oversupply. There's an urgent need to quantify these uncertainties, their impacts on the minerals industry. Otherwise, how do we actually move forward and make sure we're targeting the right metals we need to actually secure domestic supply chains? And understanding all of this is certainly going to outline more opportunities. These all sound like challenges, but every single challenge we face is an opportunity for the minerals industry and beyond. So this is just an example of supply and demand uncertainty. So we've got 4 major commodities, relatively major commodities. Copper, with a fair bit of variation in terms of pricing. These are all from about 2020. So this is about 5 years of data. Cobalt, we saw a resurgence in cobalt, but then we moved away from cobalt-rich lithium-ion battery cathodes, hence the slump in price. Nickel here, this is a spike in nickel demand, but then we saw Indonesia ramp up nickel supply, and this is why we're tailing off down here to lower nickel prices. And I'm sure we're all very familiar with this. This is the lithium price. We might be seeing a slight uptick over here, but then what happens when major producers like Thacker Pass in Nevada come on stream and so on. So all of these, this price volatility essentially reflects that kind of supply and demand uncertainty and the balance of supply and demand we're facing right now. We know demand is going to increase into the future. We can see that from the baseline trends we've got already, and the influence of the energy transition is going to accelerate that. But the question is, what sort of rate is that going to happen at, and how is that going to be matched by discovery and new mines coming on stream and new sources of metals such as from mine waste? If we look at technology uncertainties, so this is just looking at the amount of metal you need for a kilowatt hour of lithium-ion batteries in terms of the variations in cathode chemistry. So we need a lot of lithium, full stop, that's guaranteed for all of these. But if you've got an iron phosphate cathode, you need a lot of phosphorus, but no nickel or cobalt. If you've got a cobalt or nickel cathode, you know, there's various combinations here. The question is, which one of these are we going to go for in the future? Are we going to continue to have a mix, or are we going to develop something else in 5 years' time? That means we're going to have to find a completely different commodity that isn't actually shown on this graph. What about solid-state batteries, sodium batteries, iron batteries to different uses, different cathodes, natural versus artificial flake graphite, cadmium tellurides versus silicon-based photovoltaics? The question is, the question we need to think about is where we're going to be in 10 years' time. I don't know if anybody can answer that. If they could, they probably wouldn't be in this room. They'd be sitting on a tropical island drinking out of a coconut or something like that. But we need to at least think about these scenarios, model these scenarios out, and actually have a look at the uncertainties related to them. And that, in turn, will give us ideas of how what metals we're likely to need into the future, and therefore develop, you know, reasonable policy to actually support those developments. And speaking about policy, this is essentially what I'm going to be talking about for the rest of the presentation. This is the stuff I've talked about up till now, is talking about uncertainty and essentially the baselines that we know about supply and demand. But certainly policy can have an impact on mining, mineral exploration, the development of mine waste projects in a huge variety of different ways. There's things going on globally, like changes to criticality considerations. We saw Australia classifying nickel as a critical metal to shore up their industry. All of these policies are difficult to predict, but we can model impact, supply and demand, economics, timing of projects. We can also learn from past experiences. So we're all dealing with a lot of policy being thrown at us right now, but we can see what impact that policy has had in the past, learn from it, and see what impact that's likely to have into the future. Things like government funding supporting critical metal project development, tariffs in the metal sectors, and so on. Certainly, you know, this is a hot topic. I'm sure everybody in this room has discussed things like this one way or another, but the question is, what impact is this likely to have, and whether is that impact going to be negative or positive? The other thing to think about is the change of the focus of the government. Certainly here in the US, we've essentially gone from a carrot scenario where we have incentives or rewards to encourage specified outcomes to much more of a stick, especially if you think about tariffs and so on. You know, I would say that we talk about reshoring. I think we've gone from a friend-shoring scenario where basically we're trying to develop friendly relationships to countries to what you might call threat-shoring scenario where basically we're using tariffs and other threats to get what we want in terms of global agreements to give the US essentially what it needs for its economy and so on. The one thing that also is happening is a lot of uncertainty. I mean, this is just a couple of articles about American steel makers are raising prices as a result of tariffs on steel and aluminum. Copper increases, copper tariffs increase prices again. We have some speculation about gold. So this is the gold futures price over the last few days, showing the impact of tariffs and then the impact of clarification of what those tariffs actually mean and what they were being applied to. And the fact is that, the tariffs that we're seeing are certainly going to change prices, but are they actually going to achieve their aims? And this is essentially the tariffs in 2018 that were applied, comparing essentially steel imports from Canada before and after the tariffs. And you can see actually after the tariffs, we imported more steel from Mexico rather than the other way around. So all of this leads into uncertainty right now in terms of what we actually should do. And the other thing that I would talk about is, are we supporting the right things with policy? We're seeing a lot of things like this on the left. This is a company in Nevada that's being essentially having expedited permitting, a fast-track project. I don't know why the decision was made to fast-track this specific project because I don't know much about it. It's held by a private company. They've talked a good game, but they haven't actually released a huge amount of information. But if you look at other countries, this is the kind of return on investment that you see from policy in countries like Australia. So what we have here, this is essentially a little infographic showing the amount of money Australia spends on essentially what we call pre-competitive data, the resource exploration spend that directly was attributed to that, and the resource extraction value that came about as the result of this investment and this policy. One would argue that this is what we're trying to achieve here in the US. We're trying to extract more resources of all different types. And if we actually, as a business, got this sort of return on investment, then then you'd say, well, why aren't we doing much more of this? And this is something I'm going to talk about in terms of policy over the next few slides. Because what I mean by pre-competitive data is essentially publicly available geoscience data that enables the de-risking of exploration for mineral deposits, but also things like mine waste, and contributes to our knowledge of the subsurface in various other ways. It's essentially, if you actually want to do, good exploration of any type, it's underpinned by this pre-competitive data acquisition that we're doing in the US right now as a result of programs like Earth MRI from the USGS and so on. However, right now what we're seeing is something like this. So this is essentially a story from the New York Times a couple of weeks ago, talking about essentially budget cuts threatening geological surveys, the exact organizations that are generating things like publicly available maps, geoscience information. And this is my quote in this story: these cuts would just make mineral exploration harder, significant reduction in the work we can do right when we need to be ramping it up to support the minerals industry, national and economic security. So I would say that if you want policy to support what we're trying to do in this room, making cuts like this that directly affects the amount of data we can supply to industry is not the way forward. But what do I mean by pre-competitive data? It's essentially the collection, collation, and integration of basic geoscientific data by government agencies, things like USGS Earth MRI program is doing, what we do at the Bureau, and so on. It's essentially strategic regional geoscientific research that upgrades historic data sets, fills gaps by acquiring modern geoscientific data, typically at a province scale. Governments generate or upgrade data sets over areas considered to be prospective but underexplored. One question is, we've had serious mineral exploration in the US for about 200 years, maybe 150 years. Where would you say is underexplored in this country? I would say probably most of it. The fact is we haven't had the geoscience data, we need to de-risk exploration in a serious way over the vast majority of the country. Certainly where I'm from, 50% of our surface geology consists of alluvial deposits with more barren cover units over where you'd actually look for mineralization. The question is what lies beneath, and how do we de-risk this area and enable people to come in and explore for the commodities we want that form the basis of domestic supply chains. This lack of pre-competitive data to see through barren cover means about 50% of the Nevada, certainly the wider western US, is semi-unattractive for exploration. If we start to invest in this area, we know there's going to be returns on investment, but also we know that all of a sudden we're going to start making discoveries. There's examples of this this is Australia. These are the types of pre-competitive data: geophysics, geology mapping, geochemistry, and understanding things like legacy exploration data. These are discoveries, major discoveries, in places like Australia, Canada, and so on, that have all been underpinned by this pre-competitive data. The one thing that's missing here is the US, because we haven't had that pre-competitive data to enable discoveries like this to happen up until fairly recently. There's other things we should think about. We should learn from the best. Australia is certainly a good example of this. Not only do they enable the generation of publicly available data, but they actually do things like co-funding, grant programs, pre-competitive data acquisition, and drilling. You know, if you live in Western Australia and you're looking for mineral resources, even in things like mine waste now, you can actually go to the government and say, we want to de-risk this drilling, we want to find out more about this system. You put in a proposal and the government will basically fund half the drilling costs for you. The data will become publicly available eventually, but who knows? In that time, where you have the data as proprietary and confidential by yourself, you may well have made a discovery. If not, then there's no harm, no foul, and you basically have, you've used some government money to learn about something that you wouldn't otherwise known about that system. The other major policy we're learning a lot about is essentially deregulation. This is the one question I have is, will deregulation of environmental and social standards related to mining actually backfire? We've heard about the lack of attractiveness of the minerals industry, especially in the workforce area. You know, one thing that the minerals industry elsewhere has been thinking about is moving away from just economic value forms to also environmental and social value forms to actually get permission to operate. There's no point having a discovery if you can't mine it because of environmental and social challenges, especially in a country as litigious as the USA. So policy that removes some of these considerations during permitting is a potential backward step. It may not actually improve the perception of the minerals industry, but may well do the exact opposite, creating more challenges down the line, including in attracting people to the minerals industry. So I think we need to understand not just the impact of policy directly, but the indirect application or indirect outcomes of some of the policy development that's going on right now. And things like this, so this is the big, beautiful bill ending tax credits for critical minerals, the 45X tax credits. One thing I've noted in our own state, in Nevada, is basically it's already a challenge to get some players in the minerals industry to think about buying co-product production outside of major companies and outside of major commodities. And even major critical commodities may not have been interest or important targets even before this further disincentivization. We need to incentivize people to look at their deposits, to think about where they could extract critical metals, to understand the distribution of those metals, and not just, in the case of the silver state, just focus on gold to the exclusion of everything else. It's far easier to mine and extract stuff the first time around than have to revisit stuff in waste piles, especially as we're increasingly improving the efficiency of our mining approaches. So this has been a bit of a whistle-stop tour. I did say to a couple of people at lunch that it would take 2 hours, but I'm only going to keep to about half an hour. But I think we need to, especially in policy-related areas, be strategic, learn from the best, learn from industry, learn from the areas where policy is actually making a difference in terms of critical metal supply and actually the development of supply chains. Think about impact and what might actually work. Don't fund or support projects that won't go anywhere or won't make an impact. That's a hard decision to make, for sure. There's going to be mistakes made, but I think we always need to think about this And you can't just go completely the other way and not fund things, but certainly there are certain projects, certain policies, certain investments you can make that you know will have a good return on that investment because of good experiences elsewhere. We need to stop reinventing the wheel. There needs to be a broad discussion about industry data eventually being made public or not. This happens elsewhere. This, again, does encourage exploration, but it's something that isn't done broadly across the US. We need to become communicative and collaborative, not competitive. Federal government, academia, states, industry all need to work together to grow the pie rather than just cutting things up finer and finer. We need to highlight the results. We need to get positive stories out there. Rio Tinto's production of tellurium from Bingham Canyon is a good example of a good news story from the minerals industry. Basically, they're producing tellurium as a byproduct of copper. That tellurium is going into essentially photovoltaic cells. You know, they got 25 to 30 news stories out of that one change they made without a significant, huge investment. And all of a sudden, all these stories are good rather than bad, and they're good stories about the minerals industry. We need more of that to emphasize what we're doing is important to society, is important to what people care about. We need to learn what is working well, what isn't, identify region, mineral system, commodity, and supply chain specific approaches, and we need to assess what we do and its impact. And the last thing I'll talk about is going back not quite as far as I think Doug went back in terms of history, but certainly Agricola and Dere Metallica, 1556. Nay, if I understand anything, greater wealth now lies hidden beneath the ground in the mountainous parts of your territory than is visible and apparent above ground. I think this still applies, and it applies perhaps even more with things like mine waste, than, you know, it still applies now some, nearly 500, 600 years later. We've had significant time exploring, but what we need now is policy to help us explore better, help us explore new areas, and help us actually use this exploration, use this policy to develop associated supply chains as we've been talking about today. And that's it. If I have time, I can answer questions, but please feel free to email me. I've got certainly plenty of time I've got plenty of information if people are interested. But other than that, I think that's all I've got to say about the importance and return on investment of pre-competitive data and policy making. Thank you.